Greetings. This is the man who pretends to be Charles Darwin, but today I'm coming to you as the author of a popular science book known as Scientifically Thinking: How to Liberate Your Mind, Solve the World's Problems, and Embrace the Beauty of Science. This is the English version. If you prefer Chinese, here's the Chinese version. Anyway, one of the major concepts in this book is construct validity. That is, how do you know that what you are measuring is actually telling you what you want to know? And this is a problem that comes up all the time in science, because you measure something, but that doesn't necessarily tell you what you want to know. And there's a perfect example of this today with the leaves all around me and the process of photosynthesis. Photosynthesis, the leaf uses light energy, even on a day like this, which is almost, it's very cloudy. But even on a day like this, there's a lot of photosynthesis going on. The leaves use sunlight energy and carbon dioxide from the air to make all of its molecules, therefore all of the food that the plant uses and all of the food of the world, since plants are the basis of the food chain. Now, scientists often want to measure how much carbon dioxide the leaf absorbs. That tells you how much photosynthetic work it is doing. Now, that's relatively easy if you have the right equipment. It's kind of expensive, but once you have that equipment, it's fairly easy to use. Now, also, photosynthesis changes from one moment to the next. Maybe not today when there's a uniform cloud cover, but especially as clouds go across the sky and as the wind blows, photosynthesis is constantly changing. So you don't necessarily want to know exactly how much carbon dioxide the leaf is absorbing at each moment, but you want to know the capacity that the leaf has for absorbing carbon dioxide. That is, you want to know how much the leaf has invested in the absorption of carbon dioxide. And to do that, what you would need to do is measure the enzyme rubisco. Now, you do not want to know, that's a short name, you do not want to know the full name, okay? But what rubisco does is it is the enzyme that absorbs carbon dioxide from the air and sends it on the way to eventually become all of the other molecules of the plant. So what you would want to know is how much rubisco is there. But this is a difficult and expensive kind of measurement to make. But as it turns out, this one enzyme, just rubisco, is 1/4 of the entire protein in the leaf. And so if you measure the total protein in the leaf, never mind whether it's rubisco or something else, out of all those thousands of proteins, this one kind of protein is the 1/4 of the weight. So it has pretty good construct validity. Measuring the total amount of protein in the leaf is a pretty good stand-in for the amount of rubisco in the leaf. But even that isn't that easy to measure the total amount of protein. What's even easier yet is to measure the total amount of nitrogen in the leaf. Nitrogen is an element, and it is a component of many different organic molecules, but most of the molecules in the leaf that have nitrogen, most of them are proteins. So, if you can measure the amount of nitrogen in the leaf, that's a pretty good stand-in for the amount of protein in the leaf, which is a pretty good stand-in for the amount of rubisco in the leaf. And so, that brings up the question, how do you measure the amount of nitrogen in a leaf? Well, you might say, why not just go straight for the rubisco? But measuring nitrogen in the leaf is relatively cheap and easy using a method that was developed over 100 years ago known as the Kjeldahl method. And this is where you take the sample and you subject it to strong acids, and the acids break down the organic molecules. Now, I'm leaving out the details of how this works, of course. If you want to read about the Kjeldahl method, and if you want to read about titration, there's plenty of other videos that you can watch. This is not one of them. But anyway, once you've got the material in the leaf broken down, most of the nitrogen goes into ammonia, which can then be measured by titration, which is where you drip little bits of acid or base into a sample until it changes color. The color indicator indicates that you've neutralized the acid or the base. Now, that is a cheap, relatively, and easy way of measuring nitrogen in a leaf. You can't do it at home, but you don't need a big lab to do that. Well, it's also a cheap and relatively reliable way of measuring the amount of protein found in milk, as well as in a leaf. And this led to something of a scandal. In 2008, there was I'm sure some of you may remember, the melamine scandal in China, in which the milk producers wanted to make their milk appear to have more protein than it really did, especially the milk that was used for infant formula. And so what they did was they started adding melamine to the milk from which infant formula was made. And of course, melamine also contains nitrogen, and so it would also contribute to the ammonia. Therefore, the Kjeldahl method would measure it as being a source of nitrogen, just as it would the protein. In other words, when melamine is added to the milk, the nitrogen content of the milk is no longer a reliable way of measuring the protein of the milk. It no longer has construct validity. As a matter of fact, it becomes a criminal case. And especially, nobody really noticed this until infants started dying of kidney stones. What was going on there? And so the government of China quickly stepped in and found out who was doing it, and then did a lot of damage control. Well, nitrogen as a measure of protein can be faked. So how do you know that botanists aren't faking their measurements of rubisco in a leaf by measuring total leaf nitrogen? And the answer is quite simple. Follow the money. For milk producers in China, at least, there were millions of dollars, or yuan, at stake in having inflated protein content measurements for their milk. There is no temptation of that sort for botanists to inflate the measure of nitrogen in a leaf. So therefore, when you follow the money, you get also a good indicator of, there goes Fred's motorcycle, that is also a good indicator of whether something has construct validity or not. This is the man who pretends to be Charles Darwin, the author of Scientifically Thinking, Tally Ho, and Amen.